All right. I think we're live. Okay, we should be live. What's going on, everybody? It has been a long week, at least if you're me. But we're almost here to Labor Day weekend, guys. So we're just gonna push forward and finish strong, and we'll hopefully have a long weekend. So anyway, good to see you guys. If you're watching live, we have a 4:40 p.m. Eastern Standard Time live session. We're gonna keep it short and sweet today. I think we only really have two topics to cover, unless people have specific questions. If you're going through our Math Made Simple, you are probably covering either addition. With regrouping methods, or you might be in our topic on time. And so I want to talk about time, for example, because it's a way of tying things in. So, real quickly, this is the world's worst sketch. Okay, so when you do the activities that were emailed out and the homework, it's probably going to be a little better than what I'm doing here because I don't have a way of sharing computer images when I do the lives. At least I don't have that right now. But if you look right here, this is my horrendous image of two clocks. So I didn't even do the whole clock because I'm not an artist. However, I did want to show you this as an illustration and just kind of talk through. This is mainly for parents to help their learner who's going through this idea of time. We talked about in our session how really the skill of being able to count by fives is super important, especially when you're talking about time, because the intervals, as far as the minutes are concerned, are in intervals of 5 minutes, right? And so as you start from 12 and you go down, it's 5, 10, 15, 20, 25, 30, so on and so forth. That might be a really new concept for some kids who want to look at, maybe the shorthand is on a 1, so it's 1 o'clock, but then they see the long hand, the minute hand's on a 4. So they're going to say it's 1:04. That's very common as a response. In fact, I think most of our learners who, when we first went through this, they were saying the same thing. You would think so too, right? But you want to have them kind of maybe go through the entire revolution of the clock and count by fives with them so they can kind of get used to that. Okay, that's really 5. That's really 10. That's 15. 20, 25, 30, and so forth, and have them go all the way around. You might even have a nice conversation about how, see, it's 60 minutes that go by that makes the next hour. Okay, so there's a lot of like, um, I don't know, preemptive, not preemptive, that's probably not the right word, but there's a lot of preliminary things that you can talk about with your young learner before you really start this week's activity. But one of the things I just wanted to push you to consider doing, especially if you've taken the online assessment, there's a few that I would just consider some challenge questions. Once they get a good idea of how to tell time, we want to talk about, the differences between time. And so we want them to bring up their subtraction skills or even their addition skills and see if they can answer like how much time has gone by when you went from 1 o'clock, for example, on this clock all the way up to, hopefully they're able to tell you that's 1:20, right? At least if you can see my two clocks on screen, right? And so how much time has gone by, and you want them to be able to eventually be able to tell you that that's been 20 minutes, right? And so you can do it, a few different ways. You could count up, right, to get from 12 to where the long hand's on the 4. That's 5, 10, 15, 20. It must have been 20 minutes. You can have them even do it like a subtraction. Like if you have 1:20, what's 1:20 minus 1 o'clock? There's a lot of ways you could approach that. But counting up by fives is a great method because we want them to be able to compare and contrast times and be able to answer specific questions, right? And so another quick note on the time conversation, which I'm not spending a lot of time, no pun intended, on it, is the idea of a number line. So that's probably really new, especially if you're in the early grades. We're talking first, second grade, even as high as third grade. You may or may not be super familiar with number lines, and it's kind of an interesting new topic to use number lines to show time. However, it is something that is being implemented in a lot of curriculums now. So I just thought I would share it with you guys in case your learner takes to it, or maybe it's a nice tool to help bring about some concepts. So the number line, of course, is just a horizontal. That's the worst number line ever. I told y'all I'm not an artist. It's just a horizontal line on a piece of paper on a marker board in my case. And so you want to put your earlier time on the left-hand side. So I'm going to stick with the 1 o'clock example, right? And let's say, I don't know, let's say we'll stick to the same thing. We'll say that's 1:20 over here. Okay. And so, as you do a number line, I encourage you to keep it consistent to like an analog clock. If an analog clock counts by in the intervals of 5, we want to do that with our number line. Okay. At least while we're getting started. So talk about how that's really going to be representing 1:10. This is really going to be representing, 105. That's going to be 110. This is going to be 115. And then finally, that last hash would represent 120, right? So you might want to put a little dot maybe about right here on the number line and have a conversation. Let's say that's point A. And you might be like, hey, Johnny, what time does point A on this number line represent? Remember, we're counting by fives. And so hopefully they'll be able to say, well, that's 1 o'clock. I went 1 unit. We're counting by fives. That's the same thing as 105, right? Okay. And then you might see some other problems where maybe you have a point B on the number line too. And they might say, well, hey, how many minutes more is point B on the number line versus point A? Well, hopefully you can have the discussion that point B is at 120. Point A is at 105. What's the difference, or how many minutes? You think of it like a subtraction problem. There's lots of ways. You'll see kind of what they think, but maybe count 5, 10, 15. Maybe counting using the number line is a good way, because the answer, of course, is 15 minutes. Okay. And you will see a lot of questions that bring up both. Okay. The activity that you have in this week's content should have a good mix where they have some number lines in there. They have some clocks on there. They'll have 2 clocks. You have to compare how much longer has it been since, you went from this time in the morning to this other clock that's in the evening, right? And you can kind of see how they can apply some of the adding and subtracting with this new topic of time, and see if maybe that cross, those skills really connect with something as practical as this. I mean, this is a life skill that all of us have to worry about, right? How do you plan your day? How do you plan your weeks and your months and your years and budget? There's so many things you can do, and time is a huge component of that. Okay, all right. So I'm going to go ahead and switch segments. I'm not going to go super long here. We're probably like 12 or 15 minutes for today. We just have a couple things to discuss. Now, if you are in our last week of the Algebra Made Simple 8-week challenge, congratulations. First off, I'm super proud of you. That's awesome. You covered some very important topics such as percents, such as polynomials, adding them, subtracting them, multiplying, factoring skills, how to solve. These are really big topics that you got to really master when you're entering algebra, or excuse me, when you're finishing an algebra year program, right? Especially when you're going from algebra 1 to algebra 2, or even into geometry. And so if you're on our last week, I'm going to pull, let me see. Yeah, you're taking that spiral review assessment, which is going to have hopefully just a bunch of questions that you should have encountered, including linear equations. I forgot that one. Throughout the 8-week challenge, right? First couple of them will be dealing with percents, maybe the first 3 questions or so if I'm looking at the review, and then maybe even 4. And then you start getting into some slope, some linear equations. Let me see what else they have here. And then, of course, you're going to have some operations with polynomials, right? And so this will be a good a way to see if you remember what we learned, and then also just to kind of reinforce and go back and remediate as necessary. So, for example, they'll start real simple. I think the first question on that the review was something like point. I'm just gonna make this one up. It's not the exact, but they'll say take this decimal, convert it to a percentage. All right, can you convert 0.18 to a percent? This is a skill that everybody needs to have, right? You can't go out, pay tip, tax, calculate things. Well, if you remember from our discussion, to move something from a decimal to a percent, it's just a matter of moving the decimal 2 places to the right. Okay, so I'm going to convert that one more time underneath here and just show you. If the decimal is currently between the 0 and the 1, if I move it 2 places to the right, that's going to put it right on the other side of this 8. So I'm going to change that to 18.0, right? 18.0, by the way, is the same thing as 18. So the answer would be 18%. Okay, 18%. So just converting to a decimal, super handy, because you can find the percent of anything just by making it a decimal and then multiplying that decimal by, by whatever amount you're trying to calculate, right? And so there's a couple questions that just kind of review that stuff, and then you might be asked a more specific question like 15% of what number is this, right? One of the ones I see on here on screen, it says 20% of, let's see what the question says. It says of what, is 40. Okay. So that can be kind of a funny question for a lot of people. I'll just put that on screen so you can see it real quick. Okay. 20% of what number is 40? So it's easier to say 20% of 40 and then answer that for most kids. But when you start saying 20% of what, that's where I like using the part over whole equals percent over 100 tool. So for example, remember 20%, percent always goes over 100, right? And then it says of what? Well, we don't know of what. That's the whole. We don't know what that is, but we know 40 represents the part. So if you're going to use the tool part over whole equals percent over 100, this is how I would first place those numbers into that particular equation. And if you remember from the first week, that's when you cross multiply and divide both ways. All right. So x times 20, that's 20x. 40 times 100, that's going to be, let's see, that's going to be probably 4,000 if I'm doing that in my head correctly, right? 40 times 100. And then, of course, you got to divide both sides by 20. Okay. And so I would recommend just, stuff like this. Use a calculator just to make sure you don't do anything silly. But this is a way that you can answer, 20% of what, or if they, don't give you the part one time, you can put it in the right spot. So I'm just going to double check using this just so I can save a little bit of time. Once I divide it by 20, yeah, I thought it was 200, right? So the answer is 200, all right? X is 200. If you take 40% of 200, you're going to have, not 40%. If you take 20%, of 200, you're going to have 40, okay? So X equals 200, and that's how I'd answer a question such as that, right? So we covered, like I said, percents. We covered linear equations. Just as a quick reminder, whenever you're asked linear, let's say they say, tell me what the slope is, and they give you an equation that's in slope-intercept form. So slope-intercept form, as you remember, is y equals mx plus b. And let's say you have a question like y equals 4x minus 5, something like that. I'll bring it up on screen so you can see it. If they ask you to determine the slope, remember the slope is the number essentially that's connected to x, right? Because the slope-intercept form is y equals mx plus b. Y equals mx plus b. Well, m is next to x, and m represents slope. That means all you got to do is recognize that, and the slope's going to be 1 over 4. That's all you have to do. There's not really any calculation necessary. It's just up to you to recognize, hey, that equation's in slope-intercept form. So I know if they ask about slope, that's going to be this number that's in front of the x, and that's really all you need. They may also ask the same kind of question. Let's just leave the same equation up, but they'll say, well, tell me what the y-intercept is. Well, remember, b stands for y-intercept. And so if you got a minus 5 on the end, that's in the place of where b would be, right? And so that means your y-intercept or your b is the number that's over here on the end, right? So that's just a little general recap. I don't care if you're in Algebra 1, about to take the Math ACT or the Math SAT exams, getting ready for college, Algebra 2, college algebra. Linear equations is a big topic in any of those courses, and it will be assessed. It will be. You can't even call it algebra if it's not. Let's see what else we got on here. So they have some questions about, like, is this an undefined line, or is this what do you call it? A slope of 0. Be prepared where if they ask you to write the linear equation that passes through a point, once again, that's when I want you to use slope-intercept form. So for example, they might tell you that the slope is 2, and they want you to write an equation that goes through the 0.37, for example, but the slope is 2. Okay, so this is something I see a lot of in a lot of different school settings, but they'll ask, write the linear equation if the slope is this, or they might say it's parallel to this, but anyway, you got a slope and a point. Don't forget that a point is an x and a y, right? A coordinate point is an x and a y already. So for that reason, your slope-intercept form, y equals mx plus b, that is going to be very useful tool for writing the equation. Why do I say that? Well, because if you remember 3, 7 is really an x and a y, you can plug those numbers in and figure out the y-intercept, which is the other half of the information you need to write a linear equation. So I'm going to replace the m with 2, the x with, I think that's 3, right? And then I'll just leave it as plus b because I don't know what b is yet. And then I'll just solve that equation. 2 times 3 is really 6, so that's 6 plus b, okay? And then obviously I got to get b by itself if I have worked on some linear one-step equations before. And that's going to give me 7 minus 6, which is 1. Therefore, b is equal to 1. Now remember, you're trying to write a linear equation. We did all of this so that we could figure out what the y-intercept is. We already know the slope is 2. We just found out the y-intercept is b. Now we go back to the slope-intercept form and just plug those numbers in. You're done. If the m is really 2, I'm going to replace the m with 2. And if the b is really 1, I'm going to replace the b with 1. And there you go. That's the linear equation. Okay. And so there's some other stuff on factoring. I'm not covering the whole thing because I really want you to challenge yourself and see if you can remember all the content that you learned in the 8-week challenge. But that gives you a little bit of a refresher. And of course, you can always email me and reach out if you have specific questions about anything throughout your time in our courses. Okay. So anyway, y'all have a great weekend. Have a great Labor Day weekend. I'm keeping it short and sweet. We're right at about 15 minutes. That's what I was shooting for. Anyway, I'll catch you on the next one. Y'all guys have a great weekend. Bye. Talking too fast.